Hey guys, today's video is on exponents and laws and a lot of that good stuff. We're going to start with defining monomials. A monomial is a number, variable, or product of numbers or variables. For example, a number like 5 could be a monomial. Variables like x or xy, or you can multiply them all together to make 5x squared y. Just no plus or minus signs. Next, we're going to talk about a couple of the rules. I'm going to start with the product rule. That rule is when we add the exponents, multiply coefficients. Example looks like this: 3x squared times 2x. That's going to equal 6x to the third. Power rule. That's when we multiply exponents, and we're going to raise the coefficient to the power. That example may look something like this. Let's say 3x to the fourth all squared. We raise 3 to the second power to make 9, and we multiply these two exponents to make x to the 8th. Quotient rule. We're going to divide the coefficients and subtract exponents. That example looks like this. Let's say we had 10x to the 6th over 5x to the 4th. Divide the coefficients to make 2. Subtract the exponents to make x squared. Negative exponent rule. Negative exponents are when things get a little bit tricky. We're going to flip the base and exponent. A couple examples we can show is, let's say we had 2x to the negative 3 power. We're going to flip the x to the negative 3 and put it on the bottom, but now make it positive. Keep the coefficient on top. Another example looks like this. If we already have a negative on the bottom, that just gets flipped on up to the top on the numerator, and it becomes positive. Zero exponent rule. Anything to 0 power is 1. So we can have this whole big monomial here raised to the 0 power equals 1. All right, let's pause the video and keep scrolling down to more examples. Start with number 2. Here we have power rule, and then we also have product rule. Let's do this exponent stuff first. Negative 2 raised to the second power is 4, and then multiplying the exponents, 3 times 2 is 6, and b to the first power times 2 is b squared. Then we're going to use product rule to times that by 8ab to the 9th. In product rule, we multiply coefficients, and we're going to add the exponents. So 6 and 1 made 7, 2 and 9 made 11. Let's do one with negative exponent examples. Number 6 has negative exponents. So what a negative exponent does is you just flip the fraction. So in order to cancel out this negative of this whole fraction, we're going to flip it. So this is equivalent to 7w cubed over 14w to the 12th. But instead of raised to the negative 1 power now, it's just raised to the first power. Then we can do this division of quotient rule, divide coefficients, and we're going to subtract the exponents. 3 minus 12 gives you negative 9. So we're going to have 9 w's on the bottom, and that means there's a negative 9. That is it for that one. One more, let's just do number 8. Number 8, we have power rule. Going to distribute the 4 power to the numerator and denominator to make c to the 4th, and then multiplying these two to make c to the 8th. Distributing that 4th power to these two here. Negative 3 to the 4th power gives us 81. c to the fourth power, c to the fourth. Multiplying these together with 81, c, and then you're adding these together. This is product rule. To the eighth divided by c to the eighth. Then we finally have quotient rule, where we subtract the exponents. So 8 minus 8 is 0. So there's no more c's. They cancel out. So you're simply left with 81. About polynomials now. You can add and subtract polynomials, which we have done. The highest exponent in a polynomial is called the degree. And then standard form, you list from highest to lowest degree, or highest to lowest exponent. Looking at number 10, to list these in standard form, the highest exponent is 5, so that goes first. And then there is no 4 exponent, then we put the 3 exponent, then we put squared, then we put the exponent of 1, and the constant always comes last. If you have multiple variables, like here, you look at an alphabetical order first. So we work with 4a to the third power, and then we look at something with an a to the second power. Then we finish off the a's before we look at things with only b's. Those could be a little bit more confusing when there's multiple variables going on with exponents. Next thing we're going to do is going to classify polynomials by degree and number of terms. If your degree is 0, that means your highest exponent is 0. You're going to be a constant polynomial. If you have a degree of 1, that means your highest exponent is 1, you're linear. If you have a degree of 2, you're called a quadratic. An exponent of 3, you're cubic. Exponent of 4 is quartic. Exponent of 5 is quintic. If you only have one term, that means you're a monomial. If you have 2 terms, you're a binomial. 3 terms is a trinomial. And 4 more terms is a polynomial. So we're going to define each of these by a degree and then a number of terms. For example, number 14, the highest is fifth, so we say quintic. And there's 3 terms, so we say it's a trinomial. So altogether, it's a quintic trinomial. Number 17, or let's do 18. The highest degree is 4, so we say quartic. And there's only 1 term, so we say monomial. You'll have to memorize these degrees and numbers. The thing we're going to talk about is adding and subtracting polynomials, which you should know how to do already. You just combine the like terms, but you keep your exponents the same. For example, and I'm going to show you number 4 because a lot of people mess up with the subtraction. Let's combine the squareds first. We have positive 4y squareds minus 2y squareds. So we're left with 2y squareds. Next, we can combine a y minus a negative 5y. Be careful. Minus a negative makes a big plus. So we're going to add 6y. Let's see what else we can combine. We have a negative 3 minus a 1. Here we're talking about the constants. That makes negative 4. And then the last thing we can combine is we have a negative y cubed, but we don't have any y cubes here. So this is how we write it. We write 0y cubes minus negative y cubes, which makes a positive y cubed. So if there's nothing over here, you still have to write the 0. You can't just write a negative because we're subtracting a negative, which turns out to be positive. And I'm going to put that in the front here to make this in standard form and descending order of degrees. So be careful with your subtraction. If you would like, you could totally take your subtraction sign and distribute it first to all of these terms over here to turn it into a addition. We're going to skip over multiplying polynomials for this video because I'm pretty sure we can all FOIL. Something that we may not have seen is something that looks like number 9, where you have 2c plus 5d. You're going to FOIL that to another 2c plus 5d. And whatever you get there, you're going to have to FOIL it again to another 2c plus 5d. So you'll do one part first, and whatever answer you get, you'll FOIL to another one. Last thing we're going to talk about is dividing a polynomial by a monomial. Those aren't too bad. Basically, what you need to do is you need to divide each term by the denominator. So let's look what I circled in blue. If we divided 9m to the third over 3m, and then we would have to divide negative 24m squared over 3m. We do those separately, so we get 6m squared, and the other one becomes a negative 8m. Remember, we're subtracting exponents with this quotient rule. Let's do number 14. Here we're going to have to do that one, and then lastly here. So in blue, when we do this division, we get 5x squared. In pink, we get a negative 1x. And then in black, we get a negative 2 because the x's canceled out. I know this was a lot in one video with foiling, division, definitions of polynomials, and standard form. But I think this is a little more of a review for you guys. Let me know what questions you have, and see everyone next time.